Hello everyone, welcoming you to Shorup's classes, and today we are looking at the General Economics Paper 1 of IES 2022 and question number 1, and we are looking at in this video at part F and part G of the question, these two, part F and part G. So the first question is, solve the 2 cross 2 game given the payoff matrix. Now, can you observe that there is only one payoff per given per cell? That means clearly this is a 2% zero sum game. Okay, we can understand that easily. So we'll try to implement the minimax theorem to get to the answer of this. So part F. So how do we do that? Let me just draw out this payoff matrix once more. So yeah, player 1, player 2, either play 1 or play 2. So these are the two strategies, 2, 3, 4, minus 1. So what do we do in the minimax theorem? We basically try to find out the row minimum in each case. So over here it is 2 and over here it is minus 1. And here we will try to find out the column maximum. So that is 4 and this is 3. Now out of the row minimum, we'll see which one is the maximum. So that is 2. And out of the column maximum, we try to see which is 3. So max of min of the payoffs is not equal to min of max of the payoffs, right? So that basically means that you cannot have a equilibrium in pure strategy. You cannot solve it in pure strategy. So one possible way out is to go for mixed strategies, right? So what happens in mixed strategies? Let me write down the complete payoff matrix for both players. So zero sum game means the payoff of the other player is negative of the other. So 3 comma minus 3, 4 comma minus 4, minus 1 comma 1. So we'll try to find out the mixed strategy Nash equilibrium in this case, because we couldn't find any pure strategy over here, as you observe by the minimax theorem. So let me just write down no equilibrium in pure strategy. Hence we go for mixed strategy. Okay. So now let's see how we are going to do it. So let us say player 1 plays A1 with probability P and A2 with probability 1 minus P. And player 2 plays A1 with probability Q and 1 minus Q. Then what will be the expected payoff of player 1 So it will be pi 1 is equals to 2 into p into q plus 3 into p times 1 minus q plus 4 times 1 minus p into q plus minus 1 times 1 minus p into 1 minus q. Correct? And similarly, we will also write down the expected payoff of player 2. So what is pi 2? It is minus 2 into p into q plus this will be minus 3. So minus 3 into p times 1 minus q plus minus 4 times 1 minus p into q plus 1 times 1 minus p into 1 minus q. Now what does player 1 do? He chooses p to maximize pi 1. Therefore, for player 1, what will happen? Del pi 1 del p is equals to, and set it equals to 0. So that will be 2 times q plus 3 times 1 minus q plus 4 into q times minus 1 plus minus 1 times 1 minus q times minus 1 and set it equals to 0. So that will be 2q plus 3 minus 3q minus 4q plus 1 minus q is equals to 0. So 2q minus 3q minus 4q minus 3 is equals to minus 3 minus 1. That means over here what you have, minus 4 to minus 1 and minus 1 minus 4 minus 5 and minus 6q is equals to minus 4. So the q star is equals to 4 by 6, which is 2 by 3. So this is the optimal probability with which agent 1, agent 2 will operate. So del pi 2 del q2 for agent 2. So let me just write down and set it equals to 0. So what will happen? It will be minus 2p plus minus 3 into p into minus 1 plus minus 4 into 1 minus p into q plus 1 minus p into minus 1 and set it equals to 0. So minus 2p minus into minus plus 3p minus 4 plus 4p minus 1 plus p is equals to 0. So over here what do we have? Minus 2p plus 3p plus 4p plus p is equals to 4 plus 1. 4, 5, 6, 7, 8 and minus 2 will give me 6, and over here we have 5. So that means p star is equals to 5 upon 6. So the mixed strategy Nash equilibrium is p star and q star. So the mixed strategy Nash equilibrium is p star and q star, which is 5 by 6 and 2 by 3. Okay, so this is your answer to part F of the question. And now coming to the part G of the question, we need to show that TSS equals to ESS plus RSS. Okay, so part G of the question. So obviously this can be shown using multiple ways. So let me just stick to the simple linear regression model. Yi equals to alpha plus beta xi plus ui, where ui follows all the Gauss-Markov assumptions. Yeah. All right. And what's the estimated? And we estimate this model using OLS, right? Such that the y will be equals to yi hat plus ei. A part of it will be estimable and the part will be error. And yi hat is basically alpha hat plus beta hat xi. Correct? Now, what is the total sum of squares? It's basically summation I running from 1 to n yi minus y bar whole square. This is the total sum of squares. So what we can do, will just introduce a simple manipulation to break this up into what we want. So this is basically summation I running from 1 to n yi minus yi hat plus yi hat minus y bar whole square. Okay, that means basically I'm going to group the first two terms together. So if I put a second bracket, yi minus yi hat together and yi hat minus y bar together, then whole square, and then we can expand. So that will be sum over yi minus yi hat whole square. So this is the first squared term. Next is the next squared term, yi hat minus y bar whole square plus 2 times summation I running from 1 to n yi minus yi hat minus y bar. Correct? This is what it is. Now only focus on this cross product term, this part. And precisely the summation part is good enough. That is summation I running from 1 to n yi minus yi hat minus y hat is basically summation I running from 1 to n. What is the first bracket? Yi minus yi hat. It's simply ei, right? Yi hat minus y bar. So this will be, if you split it, it will be summation I running from 1 to n yi hat times ei minus y bar summation ei. Correct? This is what it is. And this part is 0, right, from the normal equations. So what are you left with? So that is equals to summation I running from 1 to n, only this part. Now what is y hat? It is alpha hat plus beta hat xi times ei. So this will be alpha hat summation I running from 1 to n ei plus beta hat summation I running from 1 to n xi ei, right? Now again summation I running from 1 to n is equals to 0, and this is also 0, this part, again from normal equations. That means ultimately what we see is that this cross product term is entirely 0. Therefore, what am I left with? On the left side, we started off with summation I running from 1 to n yi minus y bar, and now we get summation yi hat minus y bar plus summation I running from 1 to n yi minus yi hat. Correct. This part is the total variation in y, which is the total sum of squares. Coming to the last part, yi minus yi hats, right? So this is basically nothing but summation ei square, right? So this is the error variance or the residual sum of squares, the part that cannot be explained. And finally, this is the part that we can explain. So this is ESS. So finally we get our ANOVA relationship that TSS is equals to ESS plus RSS. I have taken a simple model. You can take a multiple linear regression model with multiple regresses to get to the same result. In all cases, this result will hold. Okay, so that's your answer to part G. Thank you.